Okay, so technically this should be the video for lesson 715, but as I was previewing the video that I made for lesson 714, I noticed that when I was doing question 43, I was doing some writing off the screen for question 7-43. So I'm going to go over 7-43 first, and then we will continue with the video for 715. Okay. So question 43, let's go over this again. Lee began to wonder how his diagram could help him solve his mother's equation from problem 42. So he showed his work here. So remember, when I crossed these out, I said giant 1, giant 1. And then we said, this is where I think I went off camera, 2/5 is the multiplier to go from x to 100. So if you look at Lee's thing, when he's going from x to 100, he multiplied by 2/5. And then it says, and 5/2 is the multiplier to go from 100 to x. So I'm going to bring it down again. So when he's going from 100 to x, on the way, he is multiplying by 2/5. Okay? And then 2/5 and 5/2 and 2/5, when you do cross out giant 1, it just equals 1x. Here's where I think I was off camera. So this is where we had to finish Lee's work. So all I did was I copied this down here and I crossed out the giant 1, so I'm left with x. And then on the right hand side, you still have your 100 times 5 over 2. So then you have 100 times 5 is 500 divided by 2, and then x equals 250. Other than that, I think everything was fine with the rest of 714. So I apologize to you. I had to think of a way to go over this question again without having to reshoot the entire video. So it's at the beginning of lesson 715. All right. Good. We are good. Okay. So now, a little commercial break. But let's go over here first. Whoops! Sorry, there was a cable attached. Okay, lesson 715, creating integer coefficients, the DLT for today. By the end of the period, the students will change equations with decimal and fraction coefficients into equations with integer coefficients, even though I think we were doing that with the last lesson. Okay, so your in class is 7-63 to 7-68. Your homework will be 770 to 775. Okay, now we go back here. Why does it look crooked to me? Because it is. Okay. It looks crooked on my screen. Why is that? Why is it crooked on my camera? Is it my camera? I don't know. I don't know why that looks crooked. It's gonna bother me. You know what, Mrs. Cole? I think you're just gonna have to live with it. With a little bit of crookedness in your life. Whoops, too big. Alright. Alright. Okay. 715, creating integer coefficients. Community service. The Community Service Club at North Middle School is planning to paint apartments at a local senior citizen center next week. The club needs your help to determine how many apartments they should be able to paint in a day. Earlier in the year, when only 4/7 of the students worked, so they have a group of students and only 4/7 worked, they painted 9 apartments in a day. That's not bad. Next week, all of the students will be available. A. Assume that all the student workers contribute equally to the work. If X represents the number of apartments that can be painted by all the students in the club, use a multiplier, that's our multiplier, and your understanding of scaling to represent the situation as an equation. Okay, so when 4/7 of the total students, this one's total students, they got 9 apartments done. Okay, so now we have to solve that. So based on what we did in the previous lesson, if I have 4/7, x, equals 9, because that's my original. What's the reciprocal of 4/7? I'll put a 1 there first. What's the reciprocal of 4/7? 7/4. So we get to cross those out because why? Giant 1. Then I'm left with x equals, what's 9 times 7? 63. 1 times 4 is 4. Ooh, that's not going to go in there equally. Let's ask Google. Hey Google, what's 63 divided by 4?
The answer is 15.75.
Thank you, dear. 15.75 apartments. Oh, I feel sorry for the person whose apartment didn't get all the way painted. Okay. Alright. So the next part is called... Maybe I should do this little whole thing showing. Okay, there you go, Cole. How can I make holes? Janice, the club president, began to think about how she could visualize 4/7 to help her solve the equation from the previous problem. She recalled using algebra tiles to represent x. In her mind, she visualized the diagram at the right. So if that's all the workers, and only 4, so 1, 2, 3, 4. So there's 7 pieces there. 4 are shaded because that represents 4/7 of the workers. And then these 9 over here represent the apartments. Does the equation mat represent your equation from problem 51? Yes. They shaded 4/7 of x, and that equals 9. Making sure I'm still on camera. Janice recognized that these numbers were not easy to work with since she did not have any whole tiles. After working on her paper for a while, she said, maybe I can make whole tiles using more than one set of partial tiles. So then she drew this. Oh my mercy, she went from this to this. What's her new equation as represented by the picture? Okay. So she had 1 bar here, and she appears to have 7 bars here. Okay, so now she has 4x equals, and then 9 times 7 is 63. And this is what she did. Let's put a little asterisk here as a note. They multiplied both sides by 7. Okay. Everything in camera? We're good. Right. Back side. With your team or class, discuss Janice's strategy for solving the equation. During your discussion, answer the following questions in any order. In any order? That's going to make me crazy. What made Janice's strategy different than what you did in the lesson from the day before? Okay. Janice multiplied 4/7 x by 7 to get 4x. And she did that because she made the fraction go away. Because before it was 4 7s and now it's just 4x. How many sets of 4 7s x did Janice use to get the whole number of algebra tiles? Remember we made a note on the side that they multiplied both sides by 7. Why did the right-hand side of the equation change? Oh, so what they're asking is why did we multiply both sides by 7? You know this. To keep the equation balanced or equal. Okay. How does the number of sets Janice used relate to the equation you wrote in part A? It is the same, that's an M, number as the denominator. And the fraction. So the fraction was 4 7ths, and so you multiply by the denominator, which is a 7. Okay. Question 53. Okay. Will the strategy of turning fractions into integers from problem 52 work with other equations such as 2/3 x equals 8? Consider this question as you answer the questions below. Okay. So how many sets of 2/3 x would make a whole number? So what they're asking is, what's the denominator? What's the denominator in 2/3? It's 3. Solve for x using Janice's method. How could you record your work on your paper? Okay, so if she had 2/3 x equals 8, so remember those are my two originals, and we want to multiply both sides by 3 because that's the denominator, times 3 times 3. Okay, look. This 3 and that 3, giant 1. So I'm left with the left-hand side with 2x equals 8 times 3 is 24. So then, how do I undo multiplying by 2? We divide both sides by 2, and then we will get x equals 12. Circle. I don't know why I circled that. Anyways. Show how your solution is also the number of 2/3 into 8 wholes. Like this. So 8 divided by 2/3. Okay, remember, first number stays the same. The division becomes multiplication. And then we do the reciprocal. What's the reciprocal of 2/3? 3/2. 8 times 3 is 24. That's an equal sign, by the way. Divided by 2, which is 12. Same answer. Okay. 54. That's a long one. Okay. Can I fit everything? Yeah, I can fit everything if I like that. If I make sure everything's on screen, then I won't have a problem like I did the other day. All right. Janice wondered if the method creating whole number x terms would work with decimals. Suppose an item is marked 15% off and the sale cost is $36.21. So she wrote this. Hey, hold on. If it's 15% off, why did she write 85? Oh, they're asking that. Why did she write 0.85 in her equation? If it is, marked 15% off, then she needs to pay the other 85%, or if we change it to a decimal, it's 0.85. They stick a 0 in front. I'm not going to do that. All right. Is there a number that she can multiply both sides of the equation by to get the integer coefficient so that we get rid of the decimal? Yeah. If I want to get rid of this decimal, if I want to get rid of this decimal that's attached to my x, because that's the coefficient of x, how many places do I need to move it? 1, 2. And if you want to move a decimal 2 places to the right, that's the same as multiplying by, how many 2 places to the right is 100. Multiply both sides by 100 to get rid of the decimal. I hope you're listening. That says decimal. Okay. Use Genesis strategy to solve the equation. What was the original price of the item? Okay, so here's her original up here. So she has 0.85x, put parentheses around the original, equals 36.21. Okay, we said in B that we're going to multiply both sides by 100. Okay, so if I multiply this 0.85 by 100, it moves 2 places, so this just becomes 85x. What happens if I take 36.21 and multiply that by 100? That decimal moves 2 places to the right. So 36.21. Woo, that's a big number. Okay. So then, what is the opposite of multiplying by 85? Divide by 85. Why are we doing it to both sides? So it stays equal. Ooh, that's a big problem. Okay. Hey, Google. What's 3,621 divided by 85?
The answer is 42.6.
Okay, but it's money, you guys, so we don't call it 42.6, we call it 42 and 60 cents. So I'm going to transfer that over here. $42.60. Still on camera? Yeah. Does this method work for all equations with decimal coefficients? Why, yes it does. Because you can always move the decimal, but you're figuring out how many places to move it based on the coefficient. And remember, the coefficient is the number in front of the x. So, how many decimal places does this have? 1. What do I have to multiply to move it 1 place? 10. But do I have to multiply both sides? Yes. Why? It stays equal that way. Multiply both sides by 10. They don't ask you to solve it, they just want to know how you move the decimal. Okay. What if I had, what if I had this? 0.999x. How many places am I going to need to move that? 1, 2, 3. So what am I going to multiply by? A 1 with 3 zeros is 1,000. Make sure I'm on camera. Multiply both sides by 1,000. I don't know why they didn't ask us to solve it. All right. So cool. I'm still under time. And I got to fix 714. Again, my apologies. I just didn't want to shoot it again, so I just did it at the beginning of this lesson. Okay. Okay, that's it. Your homework tonight. Question 7-70 to question 7-75. Bye.